Good evening, my dear J Warriors. I hope you had your dinner and it's time to continue our very big and important chapter of class 11th, which is rotational mechanics, rigid body mechanics. And we are on lecture number 2, where I'm going to completely focus on the concept of torque or the moment of force. And we will see how we can solve questions on equilibrium, which is associated with torque, also pulleys with masses, and the relation of torque with angular acceleration, which is also called as the Newton's second law, but in rotation. All of these concepts in today's lecture, and also we'll see a little bit of, rolling motion as well, because sometimes there are some questions in JEE mains with regards to that. Yeah. Let's begin with your captain Shreyas, your physics master teacher. I've been training, mentoring, guiding kids for past 13 plus years, guys. I did my research from IIT Bombay, did my graduation from NIT Nagpur, worked in a software engineering firm for 3 years, decided to pursue teaching because I love it, plus I love physics. When I was your age and wrote J, I almost secured full marks in the physics of J paper. And here I am teaching you, guiding you, mentoring you for physics to make sure this is the number one subject for all of you. All right. So let's begin. Hi, Rajkumar Abhijit. Welcome, Pritija Hari. Aditi, welcome. Ko Thuri, welcome. Hari, welcome, everyone. I hope you guys have all marked attendance. And yeah, dinner too is done. So, the Josh energy, everything is back on track. Session will be around 1.5 to 2 hours. Okay? Yeah. Right. Pritija, I love your quotes. Yeah. And Abhijit, you should sleep for 7 hours at your age. You are in 9th and 10th. So, yes, 6 to 7 hours is good enough. Okay. Great. Hi, Vignesh. Thank you so much, man. So, let's talk about why will something begin to rotate, or why will something rotating stop? Let's take the example of a fan, ceiling fan. Yeah, you might have all seen a ceiling fan. It is off now. You turn on the switch, it starts rotating. What was the reason why it started rotating, and it increases the speed till it reaches some maximum speed? And when you turn it off, slowly the speed, goes away until it comes to a halt. Even a top, you apply a force using your hand, it spins, but after some time it stops. What is the reason for its rotation? The reason for its rotation is because of a physical quantity called as torque, which is the equivalent of force but inside rotation. So why bodies rotate is due to a concept called as torque. The symbol of that physical quantity is T. Tau, it is called Greek alphabet. A T with a small curve at the bottom like a J, but not so big. That is the symbol for torque. And it is nothing but the equivalent of force, in rotation. So what force does in translation, same thing torque does in rotation. It is the reason, it is the cause. It gives me why a body will begin or stop to rotate. The other name for it, also known, also known, it is also known as the moment of force. Some books still use it. The moment of force is how much? It means they are talking about the physical quantity called as the torque. It is a vector quantity. It has a direction, definitely. It is having a directional property. And the simple way to look at it is, I'll just go forward and I will come back because that will make you understand it better. So we had translational motion couple of months back in our lectures, translational motion, where we had some body Okay, we had some particular body and the body will have some mass m. You are applying a force on it. You are applying a force on it. As a result of it, it begins to accelerate. So, by using Newton's law, you say F is equal to m into A. This F is the cause, is the reason. This m is nothing but the mass, is nothing but the mass of the body or the inertia of the body. This A is nothing but the acceleration that it has, dv by dt, linear acceleration that it has. So this is the force, this is the mass, this is the acceleration. Now, same way, what happens is, imagine, imagine you have some random body again, and it is associated with an axis. That means it can rotate about this particular axis. Let's say this body has some kind of moment of inertia about this particular axis. If it rotates, then imagine that body begins to rotate like a fan being turned on, or you turn off the fan, slowly it stops its rotation. So it begins to rotate, and then it has some kind of angular acceleration. It has some kind of angular acceleration. And if you multiply that angular acceleration with I, just like you multiplied acceleration with mass, just like you multiplied acceleration with mass, here you multiply angular acceleration with the term moment of inertia, not just inertia, moment of inertia, moment of inertia. This alpha is your angular acceleration, angular acceleration. You can see a lot of similarities. Instead of mass into A, you have moment of inertia into angle-wise acceleration. Then what you are providing, the reason for it to rotate, to change its speed, is tau, which is nothing but your torque, which is nothing but your reason. It is your cause of rotation. It is your cause of rotation. The cause of rotation is nothing but torque, and this is exactly similar to your Newton's law, but this is in rotation. This was your regular Newton's law in translation. Now this is your Newton's law, but in rotation. This, I think, analogy of translation on one side and rotation on other side probably brings that concept of torque in your head and becomes very clear, I hope. Okay, so torque is the reason for it to rotate. It is not an effect. Rather, it is the first thing which happens because of which it changes its speed or decelerates or accelerates, but in rotation, not translation. Is that absolutely clear? All right. Okay. Yes. Yes, I read all the comments, Pritija, not just your quotes. I read all the comments, even if some video is there very old, and I try to see as much as possible. If possible, I reply also, and many times I give hearts, or maybe, just probably put a comment saying lovely things. All right. So this particular formula is also called as Newton's law, but in rotation. So this is nothing but Newton's law in rotation. Newton's law, but in rotation. So a very important formula. So might as well block this off. Torque is equal to I into alpha, just like force was mass into acceleration. But this is not in translation. This is in rotation. This is in rotational motion. Now, moment of inertia, we know how to calculate it. In case you have forgotten, well, it is right over here, guys. Just go to the live batch, live classes, and you will see it right over here. It's also there in the playlist. Yeah. So I have dealt with moment of inertia very nicely for more than 2 hours. Okay. So you can check out this particular lecture, and all the PDFs, everything are now in the description box. but in a very different format because of Ved. And Ved not only gives you the PDF, but also can solve the doubts of this particular class. Yes, you can chat with Ved using this link. Ved can also generate questions for you based on that session. Ved can also create timestamps. Ved can also create, smart quizzes based on this particular session. So just need to log in or open it from the app. Everything will be visible. All right. Now the question comes to your mind, sir, how do I know how much torque is there? Sir, how do I calculate the value of the torque? Sir, how do I know the direction of the torque? Only then I can find alpha, because alpha generally won't be known. If alpha is known, fine, you can find torque. But sir, if I know if I want to find alpha, I will have to find the torque. So how do we calculate torque? Okay, let's understand this particular concept. Great, Abhijit, Hari, SV Ganesh, awesome, Rajkumar, very good inbox, very good, go through. Okay, so how do we calculate the value of the torque? Now, in order to calculate the value of the torque, we need two things. We need somebody to push or pull it, meaning a force. And at the same time, we also need one more thing. The force should not be through the axis of rotation. It should be slightly off. Only then it can rotate that thing. I will give you a simple example. Say this is some body, some rigid body, and right now it is at rest. And let's say I want to rotate it. Okay, I want to rotate it. I'm just showing you the axis over here right now. Okay, now if I apply a force like this, you can see it rotates. So my force is definitely causing a torque. My force is definitely causing a torque. My force is away from the axis. The axis is this one towards you. It's going in and out of the plane. I'm applying the force at a distance. Definitely it can produce a torque. It has some rotation which is being caused. But let's say the same force I apply on the axis. Nothing is happening. I'm applying the force below over here. Nothing is happening. I apply the force even at an angle, but passing through the axis. That means zero distance from the axis, nothing will happen. But even if I keep a small distance and I apply that force, it begins to rotate. See, I'm able to rotate it. Even at a small distance like this one, I can rotate it. But here, if I put it, then I don't see it rotating because I am passing through the axis. So any force doesn't matter whichever angle, but if it passes through the axis, it will not be able to generate any torque around that particular axis. Is that absolutely clear? But this moment the force is, at some distance, no matter what the angle, you will see that the torque will be generated. But the force, the moment it passes through the axis, notice right now my force is passing through the axis. If you extend the force, I know the force is ending here, but if you extend that line of force, you can see that the line of force will pass through the axis. So if the force passes through the axis, it will not be able to turn it. It will not be able to generate any kind of torque. How many of you are getting a feeling of this now? That we need a force and at some distance, but whatsoever the force line should never ever pass through the axis. The axis is this particular point O. There should be some kind of distance over here. That is very, very critical. Super duper critical. Okay, amazing. So the torque is generated, I will say, the torque torque is generated, the torque is generated by a force which doesn't pass through the axis, doesn't pass through the axis. Very, very important. Now, how do I know how much torque is there? For that, you need to just do a very simple thing. Okay, 1 second. All right. You just need to do a very simple thing. Take that force and extend its line. Extend that line of that force. This is called as the line of force, the line of control. Same way, this is the line of the force. Okay, this is the line of the force. And see how far it is from the axis of rotation or the axis that you are considering. This is the distance from the axis that it is. That is called as the moment arm. This is called as the moment arm. Many times you will see this word in some books. Moment arm is the perpendicular distance, is the perpendicular distance. Of course, this has to be perpendicular or else you can draw so many lines. Is the perpendicular distance on the force or the line of force, is the perpendicular distance on that particular force. So the torque then, is simply put, the moment arm, multiplied by the force itself. Moment arm, that means this distance multiplied by the force, gives me the value of the torque. Very simple to understand what is the value of the torque. You take the force wherever it is acting, extend that line, just drop a simple perpendicular distance. That perpendicular distance obviously should be there. That in fact suggests that the force is not passing through the axis, because if that perpendicular distance was 0, that means the line of force is passing through the axis, then there is no torque at all. So that distance, the better it is, the more torque. I mean, if that force was here, then that perpendicular drawn will be higher and you will generate a bigger torque on that body. So the moment arm decides how much quantity of torque is generated. And of course, if a larger force is applied, the stronger the cause of rotation, that means more torque will be generated. That's why torque is proportional to the moment arm as well as it is proportional to the force. More force creates more cause of rotation, meaning more torque, and more momentum, that means farther the force is, also generates a larger amount of torque. Is that absolutely clear? Yeah, is that absolutely clear? Very good, excellent. So we can find that magnitude of the torque and we can give a formal definition of the torque also in vector form. So say for example, this is our force, and this is the position vector. R is also called as the position vector of the point where the force acts, where the force is acting. You have our force itself, and then you extend this line of force, and now you drop a perpendicular onto it. Like this. You drop a perpendicular onto it like this. Now, if you observe carefully, the angle between r vector and f vector is right over here. If this is your r vector and this is your force vector, do not take this as the angle. Remember, the angle between the vectors are never chosen when their heads and tails are matching. Rather, when their tails are together or their heads are together, only then you can measure the correct angle. Right now, the head of the r vector is with the tail of the f vector. So if you slide the r vector on the top, then the tails will match and coincide. And then whatever is the angle is the exact angle between the two vectors. So theta is basically the angle between the angle between r vector and f vector. If that is theta, this is also going to be theta. If this is r, this is going to be r sine theta because this side is opposite to theta. R is the hypotenuse, so this is the side opposite to theta. So sine theta will be this side by hypotenuse. So therefore, this side is just r sine theta. Everybody gets this? So our torque is going to be nothing but the moment arm. If you notice, moment arm multiplied by the force. In this case, the moment arm is r sine theta. So I'm just going to put r sine theta over here and multiplied by the force itself. So I'll just put F over here. So the torque value magnitude is r sine theta multiplied by F. R sine theta multiplied by F. R is the position vector, F is the force, theta is the angle between the force vector and R vector. Never ever choose this angle, that is not right. It will be sine of 180 minus theta, which is still, you can say, magnitude wise same, but technically do not use that. Okay? All right. Now, having said that, there is another way of looking at the same thing. There is another way of looking at the same thing. Observe carefully. Instead of instead of writing our torque as r sine theta multiplied by F, I'm just going to rearrange it. I'm going to write it as r into F sine theta. What difference does it make? It's one and the same thing. But actually, when I write it like that, it means torque is equal to, you are just taking r and you are multiplying it with F sine theta. Now, F is also a vector. What is the meaning of F sine theta? Well, if you split force into two components, if you split the force into two components, one of the component will be like this. One of the component of that particular force will be like this, and the other component of that particular force will be like this. Now, remember, just some time back, I had told you if this is r vector, this is f vector, this is the actual angle between them. So, this pink vector is technically your f cos theta because it is adjacent to it. The one which is far away will obviously be the sine theta. So, f sine theta. So, this is my f sine theta now. This is also the value of the torque. So whether you take force and split it into two components and take F sine theta, or you take splitting of R and take R sine theta into F, still the answer will be the same. It's just your perspective. It's like if you are, I don't know, maybe Abhijit, whether somebody sees you from left side or right side, you are still Abhijit only. It's not like from left side, I am, some L Abhijit. From right side, I'm R Abhijit, like it happens in organic chemistry, right? Those chirality and achirality that we have studied in organic chemistry. No, it's still the same. So here also, the magnitude is the same, depends on your perspective, how you're approaching it. Okay. Azad, you can get the PYQ book from the link. You can just put up a comment below after the session is over. I will reply to that comment with the 7-year PYQ book. You are talking about this book, right? This book, right? Yeah, I will send you the link. Don't worry. Yeah. Okay. Perfecto. Now, there is a term for this or a short way of looking at that. This r sine theta technically is the perpendicular distance drawn on that force. So r perpendicular into F. This is perpendicular drawn on the force. Or you can also look at it as torque is equal to, you simply take R and you take the perpendicular component of the force. This is the perpendicular component. If you notice carefully, this is the perpendicular component of the force. Still, I will get the torque. So, both ways are correct. Torque is R into F perpendicular. or torque is R perpendicular into F, or simply put, torque is momentum into force, or torque is R sine theta into F. All are just the same things, just, putting that sine theta left and right is changing the manner in which you are looking at the same quantity. Is that clear? Yeah, perfecto. Oh, you are different, Abhijit, in school and JEE. Oh, that is very true for every JEE aspirant. I've seen some students don't change. They go to school and college and then they tell, sir, in YouTube J English channel, no, they told this problem can be solved like this within 2 seconds. Sir, using this L'Hopital's rule, you can get it within 1 minute. Why are you doing like this? That's it. The look, the killer look you will get in college or school, no, will be very deadly. Don't say such things. So you should behave according to the scenario. In school, yes, yes, sir, yes, ma'am. Wow, wow, what a method. Teacher is writing one big novel only on the derivation because that is there in NCERT. Papa, what will teacher do? Okay, because our NCERT is really amazing. So many pages, they will keep on confusing, same thing. And one crazy derivation. But in JEE, whatever is the shortest way, whatever is the most convenient way, we choose that. Yeah. All right. Anyways, having said that, let's also finally write down the true nature of torque in vector form. So magnitude of torque done. That final thing is actual, formula in vector form. So if this is the force vector and this is our R vector, this is our R vector, this is our R vector, and this is our force vector. And you can see there is a sine theta between them. R is a vector, F is a vector, torque is obviously a vector quantity. So how do I, show the value of, show the direction of the torque, and how do I show it in vector form? Simply put, torque vector, torque vector is nothing but R vector cross producted with the force vector. R vector cross producted with the force vector. So this is the vector way of writing it, R cross F. Now, if you see over here, R is the first vector, force is the second vector. So whenever you take cross product, you always use your right hand thumb rule, where the four fingers of your right hand initially will point in the direction of R, then slowly they will bend. You can see they are bent slightly, okay, towards F. Start with R, then go towards F, not from F to R, R to F. Wherever your thumb will point, that is the direction of torque. Very simple. So in this particular scenario, if you take the four fingers and make it point towards R and slowly bend towards F, some genius told me, sir, we can take R like this also, and then I can bend like this and get to the force also. I was like, stay like that. Stay like that. You are looking fantastic. Because when the teacher catches you like this in the examination, R is here, and the force you are taking it like that, you will look like a complete idiot. Don't do such things. Go via the shortest way. So if you see that when I'm going like this, sir, it is so long, sir, then you just move your hand around R into F, and you can see the thumb going inside. So the torque vector, is inside the plane of the board. So the torque vector is inside the plane of the board. Is that absolutely clear? How it came out to be inside in this particular case? Everyone? Perfecto. Yes, very true, Abhijit. Okay. Maxwell's cork, screw, and rule. See, how is this? Kritik. Kritik. Yes. I'll show you, man. I have some screw. So, this is that screw of that student which fell out of the head who asked that question. Sir, can I take R cross F like that? So, that screw I collected from that student only. Okay. So it fell off his head. Anyways, so this is your regular screw. What happens is, if you take this particular screw, okay, and you take a screwdriver or whatever, and you rotate it clockwise. You rotate it clockwise like this, like this. Then it goes inside. And if you rotate it anti-clockwise like this, it comes outside. So rotating it clockwise goes inside, anti-clockwise makes it come out. This is your regular screw. This is called as your Maxwell Moya. Anybody's name you can say. Pandu's right hand cork screw, Pandu's right screw, Pandu's corky screw, whatever you want to say, you can call it. This is your regular screw where you turn it clockwise and it goes inside. Because imagine if you're first pointing towards R and then towards F, then my thumb is going inside. So exactly my thumb tells me which direction is the screw going to go. If I'm first pointing here, I move clockwise, I can see that the thumb is going inside. So if I rotate it clockwise, the screw will go inside. That is why it is called as the corkscrew rule. You can give it your own name also. Is that clear? Sometimes students feel that sir has some crazy, setup over here, or maybe sir stays in one junkyard only, because anything sir is explaining, any doubt comes, sir suddenly gets one equipment and come. Some earth will come, globe will come, screw is coming, scale is coming, that is coming. That day when one toy also came when I was teaching in the Sigma batch. So yeah, I was teaching circular loop and all of that. Everything comes. So Shreyas sir is like one uh, Aladdin over here who has a genie who just gives things. Isn't it, guys? Yeah. Okay, perfect. So R cross F and direction given by the right hand rule. Okay, of cross product. So this is nothing but your cross product or vector product. Cross or basically vector product. Having said that, one last thing is the unit of torque. And maybe I can go over here and write it down. What is the unit of torque? What is the unit of torque? SI unit of torque. Our moment arm is basically distance, force is in Newton. So it is basically Newton meter. Now, a lot of people say, sir, Newton into a meter is a joule. So why can't I write joule? No, joule has its exclusive rights only for work and energy, not for anything else. Although dimension wise, it is the same thing. So dimensionally speaking, it's the same dimension of force with one more length in it. So the dimension of force was mass into acceleration, L into t raised to minus 2. You multiply with one more meter, so L's power will now become 2. So M1 L2 t raised to minus 2 is the dimensional formula of torque, which is same as that of work also. But unit wise, you will use Newton meter and not joules. Is that absolutely clear? Okay, as clear as water. Very good. Hi, Bharat. Hello, Nisha. Good evening. Good evening. Good evening. Pandu never disappoints, my dear. Yes, perfect. So now that we have understood direction of torque, value, everything, so maybe we can solve some questions starting with a direct JEE question only, and then I will go to some other questions. Because cross product is something which you have learned in vectors chapter already. The torque of the force about the origin where the position vector is, how much will it be? So what and all is given? This is basically your position vector. This quantity that you are seeing over here is obviously your force vector. And what they are asking is how much is the torque? Torque is R cross F. And whenever you have to do that, remember, you can do it separately by actually opening up the brackets and all of that, which is very lengthy. Rather, the most easy way is to first write down, over here I cap, J cap, and K cap first. If you have forgotten the method, I'm just reminding you. Then you put the first vector, which is this one, the coefficients of I, J, K. I is multiplied with 1, then j is multiplied with 1, k is also multiplied with 1. Okay, so 1, 1, 1. Then the force coefficients of ijk. First thing is 2, the next thing is 1, the next thing is 2. This is the first step of solving that particular question. Now just put a line. Now just put line because we're going to solve below it. It's just like your determinants, nothing different. Again, write down I cap. Just put up a bracket over here. Next, you put negative and then put j cap, and then lastly put positive, and then you put k cap over here. That's it. That is your next of the problem. Now, what you will do for I cap, forget the column which contains I and forget the row also which contains I. So you just have to deal with the 4 numbers. And always remember, when you have to deal with those 4 numbers, start from the top left, go like this, and come over here just like a fish, like that. So start with 1 and multiply it with 2. So 1 into 2, guys, 1 into 2 is 2. 1 into 1 is 1, and then whatever this thing and this thing is there, you just minus it. While taking j cap, forget the column which contains j as well as the row which contains it. So these 4 numbers will be there. Again, go the exact same way. 1 into 2 is 2. 1 into 2 is also going to be 2, and just put a minus sign. For k cap, forget this column and this row. You just have to deal with these 4 numbers. 1 into 1 is nothing but 1. 1 into 2 is nothing but 2, and just put a minus sign. So I think we are coming close to our answer. So this torque then will be equal to 2 minus 1 is 1. So just I cap. 2 minus 2 is 0. So 0 j cap. 1 minus 2 is negative 1. So minus k cap. That's it. This many Newton meter is the answer. I cap minus k cap, which is obviously your third option. Option number 3, which was asked in JEE 2025. Is this clear how to solve these kind of pattern of questions? Very, very simple. Y negative, that's how determinants works. So if you have studied matrices and determinants by Ninja ma'am, or you will study later on, you will see this is actually a determinant and you can open it up, and that's how it works. Okay, I mean, that's a mathematical part. I don't want to go into those details over here. Okay, because that is a part of maths. All right. Is there any relation between corkscrew and Lorentz force? Yes, man. See, everything which has right hand rule cross product, it will be related to that. But that is the beauty of my teaching. I never use these fancy terms, Lorentz force or whatever, Then there is a Fleming's left hand rule. Then there is Fleming's right hand rule. Then there is Pandu's right foot rule. Then there is Champa's left foot rule. Then there is elephant trunk rule. Then there is a swimmer's rule. Crazy rules. Don't do all that things. Left hand, this is I, this is L, this is B. Right hand, this is V, this is B. You will get confused. Just remember cross product. If you know the cross product formula, which I have just told you, it is R cross F. If you know this is R cross F, you all have right hand, right? And just take the 4 fingers, move it, see where the thumb goes. That's it. Enough. You don't need anything else. And if it is given in this vector form, you have to use the determinant method to get it. That's all. It's very straightforward, guys. Yeah. Okay, great. Perfecto. Now, having said that, let's go to some more questions where we just will figure out how much is the value of the torque. Nothing else. Or maybe just the direction of the torque. So I'm just going to make a fancy problem for all of you. And in this particular fancy problem, what we have is a nice rectangle. Okay. And what happens is it is attached somewhere, let's say over here maybe. Okay, this is basically the axis about which it can rotate. Okay, this is nothing but the axis about which this particular body can rotate. Now, there are multiple forces acting on it, starting off with this force, then you have this force, then you have this force, okay, then you have this force, then you have this force, and then you have this force, then you have this force, then you have this force, and then you have this force over here, and this force over here, and then this force over here. Okay, these are all different forces acting on it. So this is force number, let's say 2, force number 1, force number 3, force number 4, force number 5, force number 6, force number 7, force number 8, force number 9, force number 10, force number 11, and force number, let's say, 12. So 12 different forces acting on the same body at different places. I am just interested to know what is the direction of the torque for all of them. That's all I'm interested in, nothing else. I'm just interested in the direction of the torque. Okay. How many marks should I score by OBC student for NIT? I think I have made a separate video for category. If I have not made, I will see if I can make it, because it is a huge collection of data for all the categories. But let me see if I can make it. Okay. Or maybe I'll give you a rank predictor tool only, or marks predictor tool. All right. Having said that, let's start. Okay. 1, 2, 3. Start doing it, guys. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, only 12 are there. Oh, sorry. My bad. Okay. Let's start with the first force. Let's start with the first force and let's see what the answer should be. Force 1, you can see about this axis, when it is acting, it will rotate the body in the clockwise direction. Can you see that? Whenever you have to figure out what direction will the torque generate, then take that force and move it around the axis. You will see that, okay, just move it around the axis and bring it back over here. If you see that it is clockwise, that's it, it is clockwise. So the first force is creating a clockwise torque. For the second force, just move that force like this so that the axis is included inside that loop. Just imagine that the force goes like this and comes back over here and the axis is here. How is it going? Anti-clockwise, isn't it? That's it. So the answer for this is anti-clockwise. Very easy to do it by this method. Force 3, just move it around, but do not exclude this axis, or else you might go like this also and come, right? So then how do I know which way I should go and come back? Because some student might say I will go like this, some student might say I will go like this, some student might say I'll go like this. Which way you should go? Just make sure you're going around such that axis is a part of it or inside of it. So you are going anti-clockwise, so therefore the third force is creating anti-clockwise torque. Now interesting thing for F4 is that the force is, when extended, passing through the axis. Can you see that? So there are in fact multiple such forces. F4 is just one of them. When you extend the force, it passes through the axis. Even F12 is actually passing through the axis. So we can say F4 will be zero torque, no torque at all. Even F12 will be also zero torque. 13 is not there. Okay, even F9, when you extend it, it passes through the axis. Can you see that? So even the F9th force will be zero torque. Any other force which is not giving torque? No, that's it. F4, F12 and F9, all of them are passing through the axis when extended. So they will not create only any torque. Yeah, I hope this is clear. Moon, no issues. Make sure you're catching up by watching the replay of the missed part. Next thing, if you notice F5, if you move it around and come back over here, it is going in the anti-clockwise direction. So this is anti-clockwise torque. Then F6, move it so that axis is inside the loop. You can see you are going clockwise. So it is a clockwise torque. F7, just go like this. Make sure the axis is inside. Okay, you are going clockwise again. Clockwise torque. F8 is over here. Don't go like this and come back, or don't just go like this and come back. Your axis should be inside of it. So you can see you're going anti-clockwise. So anti-clockwise torque. F9 to no torque. F10, you go like this and come back over here. It is anti-clockwise. Very simple method Captain Shreyas sir has taught you. F11, just go like that and come back over here. Axis should be inside that loop. That's it. It is a clockwise torque. That's it. That is the answer. Is this method very simple? Yes or no? Sir, how is F8 towards inside? F8, 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 F8. See, F8, if you extend the line of force like this, it will go. Just take it around like this and bring it back. So, when that force is acting, no, that perpendicular distance is there. So, that force will create a torque to rotate the body anti-clockwise. Is that now clear? Because no matter whether the force is here, 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 or here, it will be the same thing. Absolutely clear? Yeah. Uh, Parmalata. Okay. Awesome. Awesome. Okay. Perfect. Cool. 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 Very good. Very good. Clear. Yes, Hari. Awesome. Why F6 is not 0? F6. Where is F6? F6. Okay. Extend F6. Extend F6. The line of F6. Do you see the perpendicular distance is there? It is not passing through the axis. That's why the torque is not 0. So always pull that force on both sides and see whether the axis is there anywhere. If it is not, then non-zero torque. F7, if you extend it, it is not passing through the axis. F8, not passing through the axis. F9, you extend it, it is passing through the axis. That's why ninth force is giving zero torque. Okay, clear now? Abhijit, see if this much is understood. I've re-explained this. So whenever the point is that if there is an axis and there is a force anywhere, let's say this is our force, just try to take that force around once like this so that the axis is inside wherever that force is rotating. So the force will create a clockwise torque. If you see there is another force, let's say like this, anywhere randomly, let's say it is over here, randomly it is over here. Okay, just take that force and make sure the axis is inside that loop. You can see it is again anti-clockwise. Okay, it is again anti-clockwise. That is the simple technique to figure out the direction now. Is that now clear, everyone? Okay. Sure, Nisha, I will note it down. In fact, I was already planning a VIT triple E strategy, but yes, I will definitely plan for it. Okay. All right. So if it is 0, then imagine some force may be over here. Okay, some random force over here. And I find out that when I extend it, it is actually passing through the axis. So then this will generate zero torque. Okay, because when I extend that force, it is passing through the axis. So you cannot contain that basically then. Okay. All right. All right. Why F4 is 0? Because you can see when the line of F4 is extended, it is passing through the axis. So that is why it is not generating the torque. But that same force, if it is here, then it will generate torque, guys. Then it will generate torque. Okay, that same force, if it is here, then see, it will move like this because if you extend that line of force, now it is not passing through the axis. So you can see that it is generating some kind of anti-clockwise torque then. Okay, I hope this is clear now in everybody's head when torque is there versus when it is not there. Okay. Yes, we are planning marathons for 2026. In fact, the PYQ marathons, you have said it, Ibu. All right, clear, Moon Artist. Awesome, awesome. Kritik, I hope this is clear. Can you explain how this much forces? Are this is just an example, man. In JEE problem, there could be 1,000 forces also. You cannot question the examiner why 1,000 forces. Where did the forces come from? We are not investigating it. We are not CID. It is there. It is there. Okay, now we will not break our head. A person is walking up the stairs with 100 kgs load. We will not question how can a person carry 100 kgs. It is there means it is there in the problem. That's all. Okay, full. All right. Awesomeness. Now that we understood how to calculate the direction, let's take more questions coming up on your screen. Here it is. Okay. The torque on a ball whose mass is m at highest point versus the farthest point on ground measured about the point of projection, point of throwing that particular body. How much is it? Okay. So let's first of all draw the question. What is asked? It's a projectile motion combined with rotational motion question. So you are taking a ball and you are throwing it at some particular angle with some particular speed. Let's say the speed is u and let's say the angle is theta. Now that ball is slowly going to go in a curved path, something like this, and it is going to land somewhere over here. All right, it is going to land somewhere over here. Now, there are 2 points which we have to consider. The first point is the topmost point. So, once when it is here, versus the second point when it is basically down over here, like this. These are the 2 places where we have to figure out how much torque is there on the particular body. Let's start one by one. Okay, let's start one by one. So, let's start with the topmost point first. So, when you are at the topmost point, on that particular mass, there is a single force acting on it, and that is nothing but its own weight, which is m into g. So mg is there. Can you see that? When you land on the ground, then that force, or when you're just about to land on the ground, the force acting is still going to be m into g. So 2 different places, same force. So distance is different, so torque will be also different. Now, in order to measure the torque, here is the thing. See guys, technically this is r vector, the position vector where the force is being applied. This is my r vector. In the second scenario, this entire thing is my position vector as measured from the point where you are projecting it, position vector. This is the first case. Slowly the r has changed because the mass has moved ahead. Are you able to visualize? Okay. Now observe. The problem is not for the second part when you are almost on the ground, because r is then actually perpendicular to the force, or the angle between the position vector and the force vector is actually 90 degree. So theta is 90. So if I had to measure the value of the torque in that scenario, if I had to measure the value of the torque when it is at the farthest point on the ground, I will just say it is r into f into sine theta. My r over here is actually the range of the projectile. If you notice, r over here is technically the range of the projectile. The force over here is actually m into g, and sine theta is nothing but sine of 90. It is already the perpendicular force or perpendicular distance. There is nothing to split for me. I don't have to split anything. Is that right? Okay. How much is the formula for range? We all know the formula for range is nothing but u square sine 2 theta divided by g into mg over here into basically sine 90 is nothing but 1. Is that right? U square sine 2 theta by g into mg. Interesting. Now what, guys? Now what do we do? G and G is getting cancelled. Can you see that? Range has G. Mg also has G. So G and G will get cancelled. And what are you going to get? You are going to get M into U square into just sine 2 theta. That's the value of the torque when you are just touching the ground. That's it. M U square sine 2 theta. Very simple. G and G will get cancelled. Okay, that is the second part. But we also had to solve the first part where you are at the highest point. So then how much is the value of the torque? Again, R into F sine theta formula we can use. But I feel that is not needed because I do not know what is this angle, and it is not theta. Let me be very, very clear. Lot of students, they think, oh, this is the angle theta. No, 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 no. Highest point is somewhere else. That is not angle theta, and I do not know what is that theta. So better to do one small modification. Instead of splitting the force, I will take the line of force. You extend that line of force and just drop a perpendicular. Just drop a perpendicular over here. This is your R perpendicular. Can you see that? This is your R perpendicular. This is the force. And just say the torque is the perpendicular distance on the line of force into the force itself. Now things become very easy. This much distance is actually range divided by 2. This is range divided by 2, only this much part. So this is range divided by 2. And what else is there over here? Force. Force is nothing but m into g. Okay, range is u square sine 2 theta divided by g. This half is there and mg is also there. G gets cancelled. I will be left with m u square sine 2 theta whole thing divided by 2. So basically the torque is exactly half as compared to this. The torque is nothing but half as compared to that. Are you getting my point, guys? Everyone, how to calculate the value of torque? It's simple now. Everybody will be able to calculate the torque no matter what the scenario is. Perfecto. Okay. No need of equation of parabola, man. No need of equation. How range becomes u square sine 2 theta by g, moon artists? Have you checked out projectile motion? Or have you seen projectile motion classes? If you have seen, then you know the formula already, else you will have to study that particular part again. Okay, so go to the playlist, it is there right over here. I have taught everything in detail. See, projectile motion I have taken proper 2 hours. It is not including relative motion. Relative is separate. Inclined plane projectile, generally nobody does. I have done it. Okay, and this is non-uniform motion. Everything I have done, guys. So please check out that particular class. Okay, I've done properly what is projectile motion, range, everything. Okay, derivations are also done in that same lecture. So please check it out. Okay, yeah, perfect. Amazing. Yeah, all these things were done. Moving ahead, moving ahead. Let's see if we can solve this particular question coming up on your screen. There is a rod which is hinged over here. This is a hinge, basically an axis. The rod has a mass of m and length of L, and it is given to me that the rod makes some angle theta with the horizontal. The question is find the torque by the gravitational pull. How much torque will the gravity apply on it? Okay, awesome. Let's see. Okay, perfect. Now Abhijit is our 9th standard student. Yeah. Tamil konjam Abhijit. Okay. So let's see, how do we do this question? First of all, show which force is acting on that rod, and the torque also we have to find of gravity only. So mg force is there. So I'm just going to show mg force. What is my r vector or position vector of the force from the hinge point or the axis point? This is that position vector, but there is some angle and all of that involved. So I have a better idea for this. Why not take the force and extend its line, then draw a perpendicular on that particular line. This perpendicular drawn is nothing but r cos theta. R cos theta. Don't get scared, sir. Usually it is r sin theta. See, the angle drawn over here is such that it is coming out to be r cos. What can we do? Okay. So the angle shown over here it is theta. If I had taken here, then it will be r sin theta. Cool. Now this r cos theta is only the moment arm. If you notice, this is your moment arm. which is nothing but that is your perpendicular distance. And that dotted line was your line of force, was your line of force. So if I have to measure the torque, this force will rotate it like this. So the torque will be in this direction. This will be the torque. So the torque will be R perpendicular multiplied by F. The perpendicular R is nothing but R cos theta, and the force is itself the gravitational pull, which is nothing but M into G. But sir, this is R cos theta, but how much is R actually? If you think now, you'll realize this is the total length, this is the center of mass. This is nothing but the center of mass of that rod. So that R should be total length by 2. So therefore, instead of R, you're just going to put L by 2. Hence, the value of the torque that I will get will be mg L cos theta whole thing divided by 2. mgl cos theta whole thing divided by 2. Is that clear how we figured out the value of the torque? Also, I know the direction of the torque because it is clockwise. If you curl your fingers clockwise, the fingers are going inside. So the torque vector is technically inside. Torque vector is technically inside the plane of the board. Okay, very good. Awesome, awesome. Amazing. Okay, perfecto. Amazing. Right. Let's move. Let's move ahead. Sir, you just now told the relation between torque and angular acceleration. And remember, it is nothing but I alpha. So, maybe if I know the torque, maybe I can find alpha. Exactly. You can find out the value of alpha if you know the value of torque. And of course, moment of inertia. Now, in that same problem, just imagine I modified it after knowing this particular thing. I said, find alpha. I said, find alpha. Well, just now we figured out, that the torque acting on it, is mgl cos theta divided by 2. The torque acting on it is mgl cos theta whole thing divided by 2. So if I have to find the angular acceleration of that rod, all I need is the moment of inertia. Because we all know that torque is moment of inertia into the value which is alpha, angular acceleration. Only thing remaining is I, because torque I already know, we figured it out as mgl cos theta divided by 2. Sir, should I by heart it? No, 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 no. Don't by heart it. It's just that I'm not going to redo the same thing again. Okay, you can call me lazy or whatever, but I'm not going to do the same thing again. It was just an extension of the previous problem. It is not something which you have to by heart. Okay, don't sit and by heart such things. Oh, what is the moment of inertia? I know the moment of inertia at the center is ml square by 12. This is the end. So the moment of inertia of the rod at the end using parallel axis theorem comes out as m into L square divided by 3. We did this question last time. This formula you remember, because every time you cannot sit and apply parallel axis theorem. Okay, ml square by 12 is not the right answer. It is at the center. The rod is not hinged at the center. It is rotating at the end. So when you're rotating the rod at the end, the moment of inertia formula is ml square divided by 3. And of course, this alpha will come. Couple of things might get cancelled over here, like the m value here, L over here, and one of the L's over here. So when I try to find the value of alpha, so I will have alpha, I will have L, I will have 3, I will have G, I will have cos theta, and this whole thing by 2. Therefore, alpha will be 3 goes on the top, G cos theta, L comes below with the number 2. So 2 times of L. So alpha is 3G cos theta. divided by 12. That is the answer. Okay? Yeah. Yeah, we can derive it. Lewis Hamilton. Wow, what a name. But I'm not going to derive it. Reason is I have derived it in the previous lecture. This was the previous lecture, moment of inertia and all of that. So when we saw parallel axis theorem and all of it, we have done it. So, the same question we have done it over here also. Yeah, perpendicular axis theorem, parallel axis theorem, right? See, we have done all this. The rod also. Where is that rod? Somewhere it was. See, this is the rod derivation. See, ml square by 3. Can you see that? Same thing, we have done it over here. And I have asked you to remember this also. Great. Okay, so in the previous lecture, remember that answer. ml square by 3 by 12 is at the center. Okay, very good. Now that we understand the relation between torque and angular acceleration, one more question we can do based on that particular concept, torque and angular acceleration. Okay, observe this carefully. If 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 a body of mass 10 kg with radius of gyration 2 meters starts from rest till it rotates till it rotates at 20 radians per second in 2 seconds. Find the torque on it. Find the torque which is acting on it. That is the question. Let's try to figure this bit out. Find the torque which is acting on it. Okay. Now there is a body, 10 kg, radius of gyration, starts from rest, rotates till it reaches this speed. In 2 seconds, find the torque on it. Well, in order to figure out the torque, what do I need? I need moment of inertia and I need to multiply it with alpha, unless R and force is given to me. Force is not given, R is not given. Oh, that is radius of gyration. It is not that R which is there in that force. I think we need to figure out I first, only then I can go to alpha and then torque. I is moment of inertia, which is mass into radius of gyration square. Mass of the body 10, radius of gyration 2. So 2 square is 4. So this is 40 kg meter square. So I part is done. That value is just 40. Now let's talk about alpha. How do I find alpha? I think this data will help me. It is rotating at this much speed in this much seconds starting from rest. Remember, kinematic equations are still applicable. So final angular velocity is initial angular velocity plus angular acceleration multiplied by time. So final angular velocity is 20. Initially, it was at rest. Angular acceleration, I do not know. Time taken is 2 seconds. Therefore, my value of alpha will be 20 divided by 2. So, alpha will be 10 radians per second square. So, the value of alpha I know is 10. That's it. I now can figure out how much is the torque. It is 400 Newton meter. That much amount of torque is going to be generated. That is a very good value of torque. Yeah, very nice, Abhijit. Many of you got it. Amazing. Awesome. Sir, on Monday, will you start a crash? Yes, Tarun, there is a crash batch for all the students who missed the previous entry points, but you need to hurry up and start watching it as soon as possible. The link for the crash is also there, I think, in our current video, or if you just go to our main channel also, you will still get it. It's not a big deal. So you just can open the links over here. The Sigma crash batch link is there on the home page only. Yeah, you can see 29th November last entry point was there, but you can still join it, and whatever 2-3 classes you have missed, you can just watch it as a recording, and all the classes are independent of each other. It's not like if you don't attend first class, you will not attend second class. There is nothing like that. There is no link. Every class is taught independently from the scratch. Okay. Yeah. All right. Let's move to one more question coming up on your screen, and here it is. Let's see. If if the if if omega is given by 2t raised to 3 minus 4t minus, let's say, sorry, 24 times t radian per second, and the is moment of inertia is 0.1 kg meter square. Find the following things. Find the following things. Look at it carefully. Number one, initial torque. Initial torque. Number one. Number two, when is the torque zero? So these are the two questions that we will have to solve. Let's take it one by one. Okay, let's take it one by one. Initial torque, and when is the torque zero? That means somehow we need to figure out torque, and it is a variable question because I can see t cube and all are there, so derivatives will be involved in this particular calculation. All right. So let's begin. To find torque, we need alpha. To find alpha from omega, I can use kinematic equations, but be careful. Kinematic equations are invalid. Kinematic equations are invalid since angular acceleration is not constant. And how do I know it is not constant? Because I can see omega is some t cube and all of that. So definitely angular acceleration will not be constant, and I'm not allowed to use kinematic equations. Is that right? Duration of the class, I told you 1.5 to 2 hours bare minimum. Okay. Okay. Now what do we do? How do I find out alpha? Well. First of all, alpha is d omega by dt, instantaneous angular acceleration, which we have learnt in circular motion. So all you need to do is take the derivative of omega. Omega is 2 times of t cube minus 24 times of t. So take that 2 outside because it is a number. So derivative of just t cube will be there, minus 24 will also be outside, and just take the derivative of t over here. So what am I going to get? T cube's derivative is 3 multiplied by t square. 24 dt by dt is just 1. So the answer is 6 times of t square minus 24. That is my alpha. Now, this will be my starting point for both the questions. Once I know what is the value of alpha, which we have got from derivatives, the value of alpha, which we have got from derivatives, which is 60 square minus 24, which is 6 times of t square minus 24. I will use this to find initial torque and when is the torque zero. This much part is clear, this procedure. Okay. Now, what is the initial torque going to be? To find the torque, we need initial alpha also. So, alpha at 0 will be 6 multiplied by 0 square, put time as 0, minus 24. So, it will be minus 24 radian per second square. That is alpha. So, the torque initially will be moment of inertia into alpha at that moment. So, moment of inertia is given to be 0.1 multiplied by minus 24. Hence, the value of the torque will be negative 2.4 Newton meter. That is my initial torque. That is my initial torque. The first part is done. Okay. Next, Next, what is that next part? Well, the next part says that we have to figure out when is this torque zero? When is the torque zero? So think about it. If the torque is zero, then it also means alpha will be zero. That means alpha will also be 0. So the value of alpha, I will substitute it as 0 and see what do I exactly get. 6 multiplied by t square minus 24. So 24 is equal to 6t square. Therefore, 6 and 24 is divisible. So 4 is equal to t square. So time is nothing but 2 seconds. I can't take the negative time. It has to be positive time only. So time is basically 2 seconds. So when is the torque 0? It is 0 at 2 seconds. So the torque is 0 at 2 seconds. That is the final answer. Is that clear? So we figured that bit out also. So these are the kind of questions that you can expect. Now let me tell you one interesting thing, which most of the books might just give you as a formula. You might not see many questions, even in JEE mains also not many questions. Just like we found the analogy between translation and rotation, instead of force is mass into acceleration, torque is I into alpha. Equivalent of mass is I, equivalent of A is alpha, equivalent of force is tau. So imagine if there is a body, if there is some kind of a body, okay, and it is being rotated about some axis. Let's say there is a torque acting on it. Let's say there is a torque acting on it, and in some time it rotates by an angle of delta theta. This is basically angular displacement. Angular displacement. If a force displaces something, that force does work. If a torque rotates a body, then the torque is also doing work. So I can then say that the work done by the torque in rotating that particular body, that work is simply the value of the torque multiplied by the angular displacement. Answer will still be in joules only. Yeah, that will not change to some other unit. Yeah, it is torque into the angular displacement. Very, very important formula. Instead of force, you have torque. Instead of displacement, you have angular displacement. Very identical looking. That also tells me if somehow I also end up knowing what is the angular speed, what is the angular speed of rotation, we can also figure out how much power is delivered by the torque. The power delivered by the torque. The power delivered by the torque. How much will it be, guys? That power, instead of force into velocity, now we will have torque multiplied by angular velocity. Instead of linear velocity, we will have angular velocity. That's it. That's the only difference, guys. So work is torque into displacement, angular displacement. Work is torque into angular velocity. One and the same thing, like in linear motion. Like in linear motion, there is no difference. You can also say that this work is the area under who versus who? Torque versus angular displacement. Torque versus angular displacement will also give me work, just like force and displacement area gives me the work done. Okay, we can do a question based out of this. We can do a question based out of this. Let's say we have we have a solid sphere, a solid sphere of mass m and radius r, and and there is a force acting like this, and there is a force acting like this until you rotate it by, you rotate this solid sphere is rotated by rotated by 180 degrees. The question is, find the work done and also the change in its kinetic energy. Change in its kinetic energy. This is the question. Let's try to solve this. Find the work done and also how much is the change in its kinetic energy. Read it again and again, see where the force is, see what is needed, what else you need to calculate it. Work done. This is a force, this is a solid sphere. You apply the force along the tangent, it will begin to rotate. 100% there is a torque which is generated, guys. Can you see? It will definitely create a torque in this manner. And you're rotating it by 180 degrees. So this force will move like this. And it has definitely rotated it by 180 degrees. So can you tell me how much is the angular displacement? It is pi radian. Always measured in radian, never in degrees. In physics maths, remember radian, not degrees. Okay. Now figure out how much will be the magnitude of the torque before going ahead. Torque is perpendicular distance. I can see that if this is the force, this would be the perpendicular distance, which is r. So it is r perpendicular into the force. So perpendicular distance is the radius of the solid sphere and the force is F only. So that is the value of the torque. Secondary thing is the moment of inertia. Do I need? I don't know. We'll see later on. But first thing which we will figure out is how much work is being done. So the work done is nothing but how much torque you are applying multiplied by the angular displacement. The torque that you are applying is R multiplied by F. Angular displacement is pi. So R F pi is the amount of work done. That is the first answer. We have just completed how much work was done. Is this clear? Torque into angular displacement, RF pi. Very simple, straightforward. Okay, awesome. Next, the question says, can you also figure out how much the kinetic energy changed by? There was a theorem in work energy chapter. The amount of work you do changes the kinetic energy. Oh, so we just have to use the work kinetic energy theorem, nothing great. So the work which is done always changes the kinetic energy. Change in the kinetic energy. And that is exactly what is asked. How much is the kinetic energy change? So the change in the kinetic energy is exactly the work done, and therefore it is also RF pi. That's it. That is the answer. That is the answer. Now, moment of inertia was not at all needed, but if it was needed for something else, we would have calculated it, and we know the formula is 2 by 5 mr square for a solid sphere. So we didn't need in this particular case the moment of inertia. Very simple. Okay, so this is how you can do it. Next question coming up on your screen. Here it is. If omega is equal to t raised to 4 radians per second, find the power is proportional to T is which power? The power which is acting on it is proportional to which power of time? That is the question. This kind of question has repeated so many times in the JEE Mains examination. Omega is given, power is asked. Wait a minute. Let me think. Power is nothing but, what is the value of power, guys? Yes, power is just like for force into velocity, I will write torque into angular velocity. Immediately, I've seen many kids get tempted and they write, oh, omega, sir, I know it is nothing but t raised to 4. So they immediately say omega is t raised to 4. So it is directly proportional to this. So t raised to 4 should be the answer. But that is where you went wrong. Do not forget, even torque is there. And torque need not be a constant. In fact, it will not be a constant because omega is changing like crazy. So torque will also be changing. So first step is to figure out how much is the value of torque. For that, we will need alpha. And alpha is d omega by dt, meaning I have to take the derivative of time raised to 4, which is 4t cube. That is alpha. Now we can say that the value of torque being moment of inertia into alpha, it will be I into 4 into t cube. That is the value of the torque. So if I write it properly, it is 4 times I times of t cube. So I need to put the value of torque as 4, moment of inertia is a constant, and t cube. This is the value of the torque which I have substituted. Now things start making sense. Oh, 4i is a constant. T cube into t raised to 4 is t raised to 7. So the power is directly proportional to t raised to 7. So the power which it is proportional to is the number 7. This can be a numeric question. This can be numeric question. Got it, everyone? I'm very good. A book. Welcome aboard. Yeah, thank you so much for asking. Great. Now that we understood torque along with power, work, and how do we calculate the value of torque, even some derivative based questions and all of that. One type of question which was of particular interest is a pulley with mass. Lot of times these kind of questions will come. So one such example where you might just have a pulley, okay, which is hinged over here, or let's say in this scenario also, and maybe there is a thread which is wrapped over that pulley, a thread which is wrapped over the pulley, and it is hanging below. And it is hanging below like this. Or in this scenario, it is just wrapped from one side to the other. And there are two masses or two people pulling it like this. Let's see. Okay. These scenarios where the pulley itself has some mass. Now you cannot ignore the mass of the pulley. This pulley's mass can't be ignored. What basically will change? I'll tell you. Let's take just a single-sided pulley. So if there is a thread wrapped around it and it is being pulled, it is attached to a mass, something is there. Obviously, there will be some kind of tension in that rope, and that tension will exist like this as it is pulling that particular rope down. So there will be definitely a tension. Can you see that? This pulley may be a solid disc, maybe a hollow sphere, maybe a ring-like pulley, or whatever it is. It will have some kind of moment of inertia. Some kind of moment of inertia will be there. Now, this tension force is applied at some distance perpendicular from the axis. That is also the radius of the pulley. So that tension will create a torque. So the tension creates a torque which causes angular acceleration of the pulley. So you will see there will be some change in speed, which means there will be alpha. And the tension will create a torque, which is moment of inertia into alpha. I is there, alpha is there. The torque will be this R into T. This R multiplied by T. Angle is 90, so you can put sine 90 also, or R into T is moment of inertia multiplied by alpha. R into F, but the force is perpendicular, so sine 90 over here. Is this clear? Is this concept clear? How this tension, if I know it, I can multiply it with R. I know I can find alpha. Or if I know alpha, I can find tension. Simple. Now, what about this? What about this? When there is a string and it is going on both sides. Lot of people I have seen, they take a tension here and they take the same tension over here and they solve that question. That is the biggest mistake. You cannot take same tension, because if the tension is same, then that same tension is at same distance from the axis. So R distance and R distance. So it will create same torque, one clockwise, one anti-clockwise. This tension will create clockwise torque. This tension will create anti-clockwise torque. So it should not rotate only, but one side will be heavier, one side will be lighter. So it will go like this. So keep in mind, there must be some kind of alpha which will be existing. So wherever that alpha is, I'll just write it down over here. Let's say this is alpha. So that way the torque should be higher. Now if alpha is like this, it is obvious this tension will be more than this tension. So the tensions will be unequal whenever you have a string which is wrapped over a pulley and the string is suspended on both sides. This is a critical thing which you should know for pulleys with mass. Okay, the pulley will definitely have some mass. This is R, this is also R. Now, because this tension will generate more torque, and when I say this net torque is I multiplied by alpha, this net torque will be first because of this tension. So it will be R multiplied by T2, and this tension will create exactly opposite torque. So negative sign. So minus R into T1. Why negative R into T1? Because this torque will create anti-clockwise torque. This tension will create clockwise torque to help alpha. So alpha is clockwise. So whichever torque is clockwise, that will be positive. This torque by tension 1 is negative because it is in the opposite direction. Is this understood, guys? Everyone? Yeah. So whenever a massless pulley is there, it's simple. Tension is same. But the moment the mass is there with the pulley, then the tension will not be the same. If it is a single rope, then there is only one tension. A dual rope, no matter how the arrangement is, tensions will be different. We'll solve the questions based on this. Don't worry. So taking a question just for you. Our same regular question where we have this particular pulley, which is in the form of a disc of mass m and radius r. And what happens is we have a thread connected like this, which is wrapped over that pulley. There is 2m mass here, or let's say, yeah, this is m, this is m. The disc has a mass of 2m and radius is r, and this is, let's say, 3m. Okay, this is how the pulley system is. Okay, right over here. Question is find acceleration. That's it. Find acceleration of that particular system. When the blocks will start moving, find the acceleration. Okay, let's start drawing whatever we can figure out. We know that this 3m mass being heavier will start moving down, so there will be an acceleration downwards. And once this goes down, the pulley will begin to rotate, and that's why there will be an angular acceleration like this in the clockwise direction. Can you see that? And once it starts rotating, this thread will go up, this mass will go up exactly with the same acceleration like this. That is the first thing which we realize. Also, we notice one more thing. In that particular pulley, especially in that pulley, each point on that particular circumference will be having tangential acceleration, something like that. Will be having tangential acceleration like this. and it continues into the thread in this particular manner. So for that pulley, can we not say that the tangential acceleration is also this acceleration of those masses? Same acceleration is continued, like that, and this becomes the tangential acceleration. Becomes the tangential acceleration here. I know tangential acceleration is alpha into r. We have studied this in circular motion. So relation between a and alpha is alpha. That is something which you can easily understand by drawing the diagram. Can you see it? So this was A, this was your A tangential. This was your A tangential. Okay, that's number one. Next, let's draw forces acting. This mass, 3 mg, this is mg. There will be tension 1 and tension 2. Never show that same tension, correct? That same tension will go over here. This will be T1, this will be T2. As you can see over here, from the center, this is R. From the center, this is also R. This is perpendicular. This is also perpendicular. I will need all of this. So starting off with linear equations, meaning if I use my net force is equal to mass into acceleration. If I use this particular equation, first for m mass, observe what will I get? Accelerating upwards, so tension 1 will be more than mg. Tension 1 will be positive, mg will be negative. So net force will be T minus mg, not mg minus T, because tension is in the direction of acceleration. Then if you use the same equation, but for 3m mass, net force is equal to mass into acceleration. Acceleration is down, so 3 mg will be more than T2. So 3 mg will be positive, T2 will be negative. Oh, sorry, I just put A over here, my bad. That will be M into A, my bad. That was M into A. Here it will be 3M multiplied by A. But T1, T2, two unknowns plus third unknown A can't solve with just two equations. We need one more equation. You might say, sir, can I use A is equal to alpha? But then alpha is another unknown. So we need one more equation, fourth equation. So I'll tell you what we can do. How about using net torque is equal to moment of inertia multiplied by alpha, and we'll apply this for that rotating mass, which is nothing but the pulley. So if you focus your attention on the pulley, this tension will support alpha clockwise. So that torque will be positive. So R multiplied by T2. This tension will create opposite torque to alpha. So it will create negative torque of R into T1. The angle between R and tension is perpendicular. So sine 90 is 1. Moment of inertia, it's a disk. So mass is 2m into r square divided by 2 multiplied by alpha. Alpha is a by r. Can you see that? Alpha is a divided by r. So I've substituted literally everything. So for a disk, moment of inertia is mass r square divided by 2. Mass r square divided by 2. Very nice. Now let's solve this. But before that, few things that we can cut. R, and this R. This R and this R also goes. This 2 and this 2 also goes. What am I left with? T2 minus T1 is equal to just MA. That's my third equation. I have a feeling that we should just add all these three equations, because when I add T1 and negative T1 will cancel. Negative T2 and plus T2 will also cancel. So maybe we can solve it for the unknown of acceleration. So I'm just going to add all three equations. Add all the three equations. So I'm just going to get T1 minus mg, 3mg minus T2, 3mg minus T2, T2 minus T1, T2 minus T1, MA, 3MA and MA, MA, 3ma and ma on the RHS. So all the LHS terms on one side, all the right hand terms on the other sides being added. Like I said, T2, T2, T1, T1 will cancel. 3 mg minus mg is nothing but 2 times of mg is equal to 1, 3 plus 1 is nothing but 5. So 5 ma, cancels. So 2 times of g is equal to 5 times of a. Therefore, a will be 2g divided by 5. That is the answer. Very, very straightforward. Got it, guys? Very good, Lewis Hamilton. Awesomeness, awesomeness, awesomeness. Abhijit, push yourself, man. Yeah, I know. Usually we don't take classes, but I'm going to make that habit now for all the students so that it's not about sleeping late, but you should sleep for 6 to 7 hours. J is around the corner, whether you are 27 or 26 student. Yeah, 28 and 29 students will give all kind of excuses. Sir, sleepy is my school. No, it was such a simple school. Little homework is there. Hardly we do anything. Oh, nicely, I was sleeping, sir. Yeah, guys, you need to slowly get into that mode. Okay, very good. There is another question which is very interesting. This was asked in 2022. Okay, but a single-sided mass is there. A disc with a mass of 4 kg, radius 10 centimeter is mounted on a axle. The block of 2 kilos is hanging from a massless rope wrapped around the disc. During the fall, the cord will not slip. Yes, because it is wrapped. Question is find the tension in the rope. Okay, very nice question. Start with the free body diagram, nothing else. Yeah. So this mass weight will be there. This tension will be there. That same tension will be there over here. All right. Same way acceleration. This mass will accelerate down. Okay. So let's start writing T, T, mg and what else? Ayo, this went off. Board has hanged. Often it happens. I don't know what to do. Okay. I'll just wait for some time. Board will come back. Auto click in Vedantu app. What is that auto click feature? I don't know. Are you no Anu Winks? You are a Mallu, so you should teach me then. I will try to say it. Oh, thank God. Came back. Okay, fine. This is basically your acceleration and then finally angular acceleration. Okay, that's it. That's the FBD. Now let's start with the question. First of all, if you use for this block, force is mass into acceleration. Force is mass into acceleration. There is a force of mg down and tension on the top that is giving that small mass some acceleration. Next stuff, for the pulley, we can also say that A and alpha are related by using A tangential is equal to A and A tangential is alpha R is equal to A. So alpha will be A divided by R. That is the next thing, just like the previous problem. So for all these kind of questions, guys, always you will see that if acceleration is there, if some acceleration is there over here, this alpha will always be A by R. Keep that in mind. This alpha will always be A by R. You can use it as a standard practice. Anyways, coming back to the question over here. Uh, if you use torque is equal to I into alpha, the torque acting, this tension is at a distance of r. So small r multiplied by tension. Moment of inertia of a disk is capital M r square divided by 2. Alpha, we just saw, it is A divided by R. Couple of things get cancelled like this R and this R remaining and this R also got cancelled. So therefore, we got the value of One second, guys. The board is hanging at times. Hold on. Yo, what to do? Come on, bro. Please. Oh, 1 second, guys. I don't know why it is hanging. Is it hot? Or am I hot? Or we both are hot? Or something is terribly wrong. Someone's done black magic. I don't know why. Oh, suddenly it will come off. Mm, only the bottom part of that board will somehow not work sometimes. I don't know what is wrong. Okay, I'll just wait for 2 minutes and then I'll do it. Hold on, guys. Not under my control. Meanwhile, I'm just seeing your chats. Wow. And guys, if you have forgotten to mark your attendance, please mark it, okay? Ah, what to do? I can't even connect it. I think I should buy a keyboard now, I feel, and connect it to this because there is no keyboard for this. This is just an independent computer. It's not connected to anything. It's just one power switch and one internet. That's all. There is no keyboard for this. If I had keyboard, then at least I will press Control Alt Delete Task Manager, something I will do, no? Or put Alt Tab. Nothing I can do now. See? I'm scared of doing anything else. Okay, I'm just restarting the system. Ah, something happened. Wow. Okay, come, bro. Amazing. Oh, finally. I think I found a hack. I should do this, I think. Okay, anyways. So where were we? Over here, right? Yeah. So the tension will be nothing but MA divided by 2. I think we have to find tension, right? So why not substitute the values and maybe we can get something. Put the value of tension over here. So we will get, therefore, if I substitute this value of tension into this particular thing, what will I exactly get? Let's write it down. I'll get small mg minus capital MA divided by 2. Capital MA divided by 2 is equal to small ma. So therefore, small mg will be a common capital M by 2 plus small m. Okay. So small m is how much? It is given to be 2 kilos. G is how much? It is 10. A, I do not know. Capital M is how much? 4 kilos divided by 2. Small m is 2 kilos. So this will become basically 20 is equal to A multiplied by 4 by 2 is 2, 2 plus 2 is 4. So from this we are getting acceleration as 5 meters per second square. But that's not what I want. I want the value of tension. So use this equation and see what exactly do you get the value of the tension as. Tension is capital MA by 2. Capital M is 4 kilos divided by 2. A, we just got it as 5. 4 5s are 20. 20 by 2 is 10. So 10 Newton will be the answer. Yeah. So basically 10 Newton. Yes, per 10 Newton is the answer. Understood, guys, how to solve these kind of questions? This was a JEE 2022 question. For the linear moving mass, use F is ma. For the rotating mass, use torque is I alpha. I, you know how to calculate or remember the formula. Torque is R into F. Use it. Single thread, simple. If multiple threads are there, then you have no other option but use R into T2 minus R into T1. That will be the net torque, which will give me I into alpha. That's all. And rest is just solving these equations linearly. Now, I will keep a homework question also for all of you. Please try to solve this as homework. Okay, this is your homework question. Last time many people have commented the answer of the homework question, so I want the same thing to be done. Answer should be there in the comments. Don't worry, you will get the solutions as a PDF. The PDF will be there in the description box. There is a link. Click on that link. Vedai will open up PDF, smart notes, quizzes, everything is automatically generated using Vedai. Okay, perfect. All right. Okay, amazing, 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 amazing. Sir, I took R as 100 centimeter or 10 centimeter. I'll tell you what, whatever is the radius doesn't matter. Anyways, it got cancelled out. Do you see that? R got cancelled out. So this value doesn't matter only in the problem. So whether the units are different, value is different, doesn't matter. R anyways got cancelled. This is the homework question. Now let's go to the last part, which is basically your equilibrium related questions. Yes, we have some equilibrium related questions, and then we start with force couple. Now, what is a couple? Pandu, Champa, right? Husband, wife, boyfriend, girlfriend, है ना? So that is a couple. They are equal but opposite. They're fighting. So, my dear students, this couple in physics also fights. Meaning two forces equally strong, but in opposite direction, not at the same place, at two different places. So this Pandu, this Champa, they are fighting with each other, but not at the same place, at different places. Think of it like that. That is basically a couple. So a couple is nothing but two equal and opposite forces separated by some distance. Separated by some distance. Separated by some distance. Let's say the distance by which they are separated is over here, and not 2D, I'll just call it as, let's say, L. They are separated by some distance L. Then you will see this force and this force will cancel each other, not torque-wise, linearly. So if somebody had to calculate what is the net force because of a couple, one of the force will be positive, the other force will be negative. One is I cap, one is minus I cap, one is J cap, one is minus J cap. So it will cancel and you will get 0. So basically they will be balanced in translation. So net force is 0. Therefore acceleration will also be 0. Okay, this is all about translation. So translation won't be there whenever there is a couple force. Both the forces will act, but they will not be able to translate the body. What they will be able to do is rotate the body, not translate, just rotate. So if somebody tries to calculate what is the net torque on it, then this force will create a torque like this at a distance of x2. So I can say it is x2 multiplied by F. This force will also create same direction torque at a distance of x1 from this particular point. I'm measuring the torque from that particular point, P. So plus x1 multiplied by F. So it will be nothing but x2 plus x1 multiplied by F. This is x2, this is x1, x2 plus x1 is the total distance between the forces, which is L multiplied by F. So the net torque clearly is not zero. That means alpha is also not zero, and we are talking about rotation is there. Okay, rotation is there. So the torque is L multiplied by F. This is a formula which you should remember. And of course, net force is zero, acceleration is zero. Also very, very important. So for a couple, net force is zero, net torque is not zero, and the net torque is the distance of separation multiplied by any one force. That gives me the net couple torque. This concept is mainly used in electricity and magnetism in 12th standard, where you learn about electric dipoles and magnetic dipoles. Not so much in 11th standard, okay? But yeah, you will learn this in electrostatics. You will be using this. There will be two charges equal and opposite, and there will be some electric field, and that will start rotating. There will be a torque on it, and that torque is a coupled torque because equal and opposite forces will be acting on it. Okay, I hope this is absolutely clear. So, a given formula for acceleration is mass multiplied by Pulley in nurture series. Oh, yes. If you want that, I can give it to you. That is a shortcut trick. I thought I will keep it for some other day. But yeah, there is a shortcut trick also for solving some questions, but I deliberately don't give it in the initial phase because I know when I give the shortcut trick, no, students stop solving the questions in the normal way. And then what happens is you don't learn the concept. And there are some questions where you have to use the regular way. You can't use shortcut techniques, and that's when you will struggle. So deliberately I have kept it because in some other session where I'm doing revision and some tricks, that's where I give those shortcut. Okay, right, all right, perfect. Now that we understood, okay, this is two forces equal and opposite, so that is not creating any translation, but it is creating rotation. In a very particular or specific case, it is quite possible that you have some body, and there are not just one but multiple forces, not just one but multiple forces are there like this, and all these forces maybe cancel out each other. So F1 plus F2 plus Fn in the vector form, they cancel out each other. In such a case, I will say the body is in translational equilibrium. Translation equilibrium, which also means that the acceleration of the center of mass is zero. So wherever the center of mass is, doesn't matter, like just showing this is center of mass. The center of mass is not accelerating. That is the meaning of translational equilibrium. That means all the forces vectors are cancelling, but each force will create a torque, and maybe if you take torque 1 plus torque 2 like that till the nth torque, where each one of them is R1 cross F1 plus R2 cross F2 like that, Rn cross Fn. If that is zero, then it is just said to be in rotational equilibrium. Rotational equilibrium. And the meaning of rotational equilibrium is angular acceleration is not there. Yes, zero angular acceleration. So that is rotational, and this is translational equilibrium. Many questions on rotational equilibrium. Something is there, it is not rotating, it's just standing there. That's it. Rotational equilibrium. And I will give you a brilliant example of that. Don't worry, of specifically rotational equilibrium. Okay, observe this diagram, very nice diagram. This is of a bike who is going on a curved track. So this is our bike. This is See if you're able to visualize this bike fellow is going on a curved track, and you might have seen when a bike is turning, the person will bend. What is the reason for that bike fellow to bend? Okay, let's try to visualize this. Are you able to visualize why is that person bending? We are trying to reason it out. I will choose a frame of reference. I will choose a frame of reference which is rotating with the bike, which is rotating with the bike. So in that rotating frame, I will see that the bike fellow is at rest, but the whole world is rotating around me. So for me, the bike fellow is at rest in equilibrium. See if you're able to visualize it. Okay. All right. So let me show you that particular frame. Okay. So this is my frame, which is co-rotating with the bike. This is at distance r. So in the rotating frame, by the way, any such rotating frame is non-inertial frame from circular motion. The bike, the bike is going to be at rest. That means it will be in equilibrium. So all the forces must cancel out each other. So what kind of forces are there? The center of mass of that entire system might be here. So the center of mass will experience its own weight. So mg is the weight acting downwards. At the same time, there will be a normal force over here. So this normal force will act upwards like this from the ground surface. The friction will try to give it the necessary centripetal acceleration. So the frictional force must be in this direction. Are you able to visualize this? Why the friction will be like this? This is the friction. That friction will give the centripetal acceleration. We are in a rotating frame. In a rotating frame, there is no such thing as centripetal acceleration. You are just seeing the bike is at rest. The whole world is revolving behind you. Okay, that's all you're going to see. One last thing, and that is from the same center of mass, you are going to experience a pseudo force which is Fp, which is nothing but centrifugal force. So by translational equilibrium concept, the forces should be balanced. That means normal will be balanced by mg. This is in the y direction, and in the horizontal direction, the friction minus Fp will be equal to 0 in the x direction. All the forces will cancel out each other for translational equilibrium. But if you take rotational equilibrium, very interesting thing. About this bottommost point, then the friction and the normal are passing through the axis. So they can't generate only any torque. The friction and the normal are passing through this point about which you can topple or rotate, and they will not create only any torque. So when I write down torque by friction plus torque by normal plus torque by the weight plus torque by the pseudo force, which is centrifugal force, is equal to 0, because the net torque will be 0. Friction and normal will not create only any torque because they are passing through the axis. They are passing through the axis. So no torque. But centrifugal force, as you can see, it is going like this about this point. So it will definitely create a clockwise torque. So centrifugal force will create a clockwise torque. And what about the weight? What about the weight? The weight will create anti-clockwise torque. So you will see that the mg force is going to create an anti-clockwise torque, and the pseudo force, which is the centrifugal force, is going to create a clockwise torque. that will balance out to be 0. So that is what is at play over there. Yeah. How you concluded it is in equilibrium? Because I am rotating with the bike fellow. As the bike fellow is going like this, I'm just seeing it. So what I will see, the bike fellow is at rest. So hence it is, anything at rest is in equilibrium. Converse is also true. If it is in equilibrium, it is at rest. Same thing. Got it? Rest, equilibrium, equilibrium, rest, one and the same thing. Clear? Okay, perfect. Rotation at least 3 to 4 days. And then you need to give a gap and again practice it after 1 week. Because rotation takes some time to get into your head. And then after 1 more week, you should practice one more time. You don't have too much time now, especially if you are 2026 student, but rotation, EMI, electromagnetism, SHM, these are big chapters which you might have to come back at least 1 or 2 times. Only then you will get it. Okay, very nice. Awesome. So let's do one more question coming up on your screen, and here it is. There is a square sheet. There are multiple forces. Find if it remains at rest, what is that unknown force which I am showing over here? Something similar to our previous question where there is a rectangle and multiple forces, but this time, all the forces are balanced and you just need to figure out one force. Okay. First of all, couple of things over here. I'm trying to measure the torque, let's say about this particular point. Then all the forces, torque should be 0. Yeah, perfect. Then if I measure the torque about, let's say, this point, also all the forces torque should be 0 only. Interesting. Now, if I measure the torque about this point, one very interesting thing happens. This 10 Newton and this 10 Newton are passing through the axis only. They are passing through the axis only. So they will not create any torque. This and this will not create torque because the force is passing through the axis. Not just that, even this 10 Newton force is passing through the axis. So even that will not create any torque. Oh, what about this 10 Newton? Yes, it will create a torque. This is rotating like this. So it is creating a clockwise torque, as you can see. This 10 Newton is also making it go in the clockwise direction. So this 10 Newton also will create a clockwise torque. There is only one force remaining, which is this one. And this force about that axis is going anti-clockwise. So this force will be the only force creating anti-clockwise torque. Did you understand the directions and who is 0, why? Yeah, this, and this, all the forces are passing through that point of axis, so no torque. How did I decide point A? You can take any point. I'm just choosing one point A randomly. Had I chosen this point O to measure the net torque, then this force would have passed through that point and hence no torque will be created by that guy. So depending on the point that I'm choosing to measure the torque, something will be 0 or not 0. Is that clear, everyone? Perfecto. Now what happens is, if you write down how much torque is being generated by this force, well, this is the perpendicular distance, which is 10 centimeter. So 0.1 meter multiplied by that force, which is creating anti-clockwise torque, should be perfectly balanced. This should be balanced by whom? Two other torques. One is this guy, who is already at 10 centimeter. So meaning 0.1 meter multiplied by 10 Newton. This is clockwise. And one more clockwise torque, this guy. If you extend that force, the perpendicular distance is still 10 centimeters only. So one more torque of 0.1 meter multiplied by 10. So what am I going to get? On the right hand side, 0.1 into 10 is 1 plus 1, which is basically 2. And on the left hand side, I just have 0.1, which is 1 by 10 multiplied by F. So F will be 20 newtons, which is option 1. How many of you got it? Answer is basically option 1, which is basically 20 Newton. Is this clear, everybody, with me? Perfecto? Cool? Yes. Amazing. 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 All right. All right. I will take the sessions for AEEE also, and JEE 2026 marathons are starting next week. And from Monday onwards, 5 o'clock classes are starting for JEE 26 students. Okay, even 27 students can attend, but specifically morning 6 o'clock sessions are starting, not 5 o'clock, 6 o'clock. Okay. Now, let's do a particular question like this. These are some interesting questions. A uniform mass of 250 grams having some length is balanced on an edge. A mass of 400 grams is suspended to maintain the balance of the rod. The mass suspended at 90 centimeter mark is how much? Let us first visualize the question. So we have a scale like this. Imagine we have a scale like this. The mass of the scale is 250 grams having length 100 centimeters. It's balanced on a sharp edge at 40 centimeter mark. So 40 centimeter mark will be somewhere over here. Somewhere over here. This is that 40 centimeter mark. So now I know if I had to measure this much distance, that is basically our 40 centimeters. Okay. That is basically your 40 centimeters. Okay. A mass of 400 grams is suspended at 10 centimeters mark. 10 centimeters mark is over here. So I am taking some mass and putting it over here. Okay, that is how many grams? 400 grams. And I'll just put it over here, 400 grams. But this distance is barely 10 centimeters. Okay. To maintain the balance, you are keeping another mass at 90 centimeters. Okay, this is 90 centimeters mark. Some another mass you are keeping over here. I do not know its value. M grams is it. Okay, and this is at 90 centimeters mark. That means I know one thing. Okay, this much alone is just 10 centimeters. Okay, and this much is 60 centimeters from this edge. Okay, all these things I know. Question is, how much is this mass? Okay, question is, how much is this mass? It's just about balancing the torques, guys, nothing else. First of all, the entire rod's center will be here at 50 centimeters. That's where the weight of the rod will be. This is where the center of mass of the rod will be. Okay, so this will be exactly at 50 centimeters mark. So that is 250 grams. So 250 G. G is acceleration due to gravity, not G grams. Okay, so that is one thing. All right. What else can I talk about? Okay, how much will this distance be? If this is center of mass, this will be exactly 10 centimeters. Okay, because that should be center of mass. This is 400 grams, so its own weight 400 multiplied by G will be here. This also will create its own weight. So this will be M into G, and this will be 400 multiplied by acceleration due to gravity. Now, from this pivot point, how much will this distance be? Let's think. If this is 10 centimeters, 40 centimeter mark, this is 10 centimeter mark, this much distance will be 30 centimeters. Check this out. This will be 30 because this is the 40 centimeter mark where you are keeping a sharp edge. This is 10. So 40 minus 10 is 30. From the same pivot or the edge, how much will this be? Well, this is 90 centimeter. This is 40. 90 minus 40, guys. How much will it be? It will be 50 centimeters in length or distance. Just check this out. So these are the three things which I'll need because now we can solve the problem. I'll tell you how. This 400 grams about this edge will create a torque in anti-clockwise direction. This 250 and M, both of them will rotate the rod in clockwise direction, so that torques must be balanced. So on one side, you will have anti-clockwise torque, and on the other side, you will have two clockwise torques, which are basically balancing each other. How much is the value of the torque? It will be R into F, that's it. Take CGS units if you want, 30 centimeters into 400 gram, and here it will be 10 multiplied by 250 G, and one more thing, this will be 50 R multiplied by force, which is M into G. That's all. So just solve this, guys. G, 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 0, 0, and one more 0 gets cancelled. See what are we getting? All right. So 3 fours are 12. So I am getting 1, 2, 0, 0 is equal to, this is 250 plus 5 times of M. If you can divide it by 5, this will be 50 plus M, and divide this by 5. 120 divided by 5, guys. Yes, 24, and put one more 0. Yeah. So take this on the other side. This will become 190 is equal to M. So the mass is 190 grams. There you go. That is the correct answer. 190 grams. This was your JEE 2025 question. Is that clear how we solved it? Just balance all the torques from all the sides. Very good, very good, very good. Excellent. Excellent. Now, I will just talk about few more things, which is the concept of rolling, where you might get sometimes some questions. So it is better to talk about it right now. Okay. So we'll talk about that as well. So, see, guys, we know that when you apply a force, that body will accelerate. There is translation. When you apply a torque, it will rotate. It will have angular acceleration. Can both of them occur together? Translation and angular acceleration? The answer is yes. So, when you apply a force on a wheel, it is not only translating, like the center of mass is not only translating, but also the wheel is rotating. And that's why you will see any point on that wheel will go like this in a very nice curved path. So, there is rotation and also translation. So that is basically your rolling motion. You take a ball and you roll it on a sphere. You take a marble, let it fall. You take the wheels of a car or a bike, or you take a roller paint, or you take any yo-yo which is unwinding itself on a thread. It is basically rolling motion, where you will see there is translation happening and a rotation happening simultaneously, but in a very specific way, such that the point of contact, whenever it is like this one, as it moves, never has instantaneous velocity. So whenever that point of contact comes to the bottom, all right, you will see it is always going to be at rest. That is the specific case about rolling motion. So whenever a wheel will roll, you will see that the point of contact is always going to be at rest. The center of mass will have some velocity. The center of mass will have some velocity v. The topmost point will have exactly double the velocity, which will be 2v. Very, very important. 0, v and 2v. Because this point will just translate, but the topmost point will translate and rotate. Both will be happening, and because of that, it has higher velocity. And at the same time, of course, this entire thing is spinning. So there is angular rotation, angular speed also, omega. And for rolling case, this velocity will always be equal to omega multiplied by r. Very, very important. This is the velocity of the center. This is nothing but angular speed of rotation, angular speed of rotation. Always this will be true. Not just that, you will see that it might even have some kind of tangential or centers acceleration and also angular acceleration like this. Just like v is omega, even the center's velocity will be related to center's acceleration and angular velocity will be related to alpha. So A will also be equal to alpha for a specific case of rolling. So whenever a body rolls, the center's acceleration will be angular acceleration multiplied by the radius of that wheel or that whatever object it is. Okay, these are very, very important points which everybody must know. So this rolling motion is nothing but translation plus rotation. So it is nothing but you are having all the points of that particular thing translating. So there is translation which is happening and you combine it with just rotation, meaning this point will not have any velocity, this point will be going down, this point will be going behind, this point will be going up, this point will be going like this. So there will be rotation. What you get is rolling motion. That is why you see the topmost point not only has v velocity, it also has omega r, which is also v. So this v and this v together gives me 2 times of v. But the bottommost point has a velocity v forward and also a velocity v backward. So they cancel and they will have no net or resultant velocity. So the topmost point of a rolling object has double the speed as that of the center, but the bottommost point has no speed at all. You can see the topmost speeds are added to 2v, the bottommost speeds are cancelled to make it 0. Very, very important. One last thing about rolling is that if you take any rolling body on any rough surface, inclined, whatever, doesn't matter. So there could be multiple forces acting on it. Normal, maybe some thread is there, some friction will be there, all of that. But the friction will always be static if it is in rolling condition. This is very, very important. When it is rolling, the friction will be always of static condition because the point of contact is at rest. Do not forget that. This particular contact point is going to be at rest. Hence, the friction is static in nature. And then the rest of the things you can apply. So it might have some acceleration and alpha and all of that. So maybe some linear acceleration is there, angular acceleration is there and all of that. But friction will always be static. Now you apply your regular F is ma, torque is I alpha, all those equations, and you will get the answer. One more thing, when you apply all these things, because the force acts on a point which is not moving, the work done by this static friction is also 0. So the work done by this rolling friction is always going to be a big fat 0. And because it is 0, you can say for a rolling body, energy will be conserved. So mechanical energy is constant for a rolling body because friction is not working. It is conserved. Very, very crucial information. Okay. Friction will not do work. Friction will act, which will be static in nature, and mechanical energy is conserved. All these are critical points. Maybe we can do some questions based on this so that you guys get an idea. Okay, here it comes. There is a force of 49 Newton which is applied on the highest point of a solid sphere kept on a rough plane. If the sphere rolls without slipping, then what is the acceleration of the center of the sphere? Let's analyze this. In this particular problem, it is clearly mentioned it is rolling. There is no slipping condition. Okay. There is a force at the topmost point, and that force is given to be 49 Newton. 49 Newton. Apart from this, which other forces will be there? At the point of contact, obviously, normal force. And from the center of mass, obviously, the weight. So, I can say sphere of mass 20 kg, right? So, 20 g weight will be there, and there will be a normal force also, from the ground over here. Apart from that, there could be some friction. I don't know which side it will act, but chumma I can assume something. If I'm wrong, I will get negative value. That's all. But otherwise, everything will be fine. So just taken friction in one particular way. Lastly, the center of mass will have some linear acceleration, which is A, and of course, some angular acceleration, which is alpha. And do not forget, A will be alpha multiplied by R because it is rolling. Rolling. Okay. Now, what do? We have drawn the free body diagram. What next? Let's use our Newton's laws equations and see what do we exactly get. So, basically, if I use the net force is equal to mass multiplied by acceleration, here the force is 49 Newton minus the friction is mass of the entire body, which is 20 multiplied by A. 20 multiplied by A. Okay, I'll just keep it as it is. All right. Let me also use torque. Torque is equal to moment of inertia multiplied by angular acceleration. Let's see what do I get. If I take this particular point, the normal and the weight are passing through the point, so they can't generate any torque. The normal and the weight are passing through the axis, so they can't generate torque. But this force will rotate like this and create a clockwise torque in the direction of alpha. So it is helping it. And that force is at a distance of the radius of the sphere. So I can write R multiplied by the newtons, which is 49. This friction is also going to give clockwise torque to help alpha, and that frictional force is also at the radius distance to provide that particular torque. Okay, so plus R multiplied by whatever that friction is moment of inertia. What is it? A solid sphere. So solid sphere's moment of inertia is 2 by 5. Mass, which is 20, multiplied by R square. Alpha, we all know, is A divided by R. So once everything is substituted, I know you are thinking, sir, R was not given, but don't worry. Anyways, R just got cancelled. So therefore, 49 plus F is equal to 5 and 20. What will happen, guys? It will become 4. 4 2s are 8. So it will become 8 times of 8. Now I got these two equations. Think what we should do to find out the acceleration. It's quite obvious actually. Add both the equations. Yes, take this particular equation and take this particular equation. Just add both of them. Things will become very sorted, guys. So it will become 49 minus F plus 49 plus F is 20A plus 8 times of A. So 49 plus 49 is 98. FF got cancelled. 20 plus 8 is 28 times of A. So A will be 98 divided by 28. How much will it be, guys? Yes, approximately. Approximately. Come on, my dear warriors. How much will it be? Very good. Very good. 3.5 or 0.35 or 0.45. See, you can think 98 is almost like 100, 28 is almost like 30, 33 is a 90, So it will be slightly more than 3. So this can be taken as 3.5 meters per second square. Yeah, that's it. That is the answer for this particular question. 3.5 meters per second square. Is that clear? Everything done, dusted? Yeah, 3.5 meters per second square. How many of you got the answer? Very good. Very good. Excellent. Now, the last thing about rolling is when you have an inclined plane, and there is a formula for it which you should know along with the free body diagram. And this inclined plane is making some angle theta over here. The inclined plane is making some angle theta over here, and this body will start accelerating down like this. This body will start accelerating down like this. It will also have some angular acceleration, of course. So there will be multiple forces acting on it. Its weight, then friction, then normal. All these forces will be there, of course. Normal will be there, friction will be there, its weight will be there. So using Newton's laws again, simple, F is ma and torque is I alpha. The formula that you get for acceleration is very, very important. It comes out to be acceleration due to gravity into sine theta, whole thing divided by 1 plus I, moment of inertia, I, whole thing divided by m into r square. That's all. That's the formula that you get. And now, by heart this, say for example, we take a hollow sphere. For hollow sphere, what will be the acceleration be? G is there, sine theta is there, 1 plus moment of inertia of a hollow sphere is 2 by 3 mr square divided by mr square. So this will be G sine theta 1 plus mr square cancels 2 by 3. 1 plus 2 by 3 is 5 by 3. So 3 goes on the top. So 3G sine theta whole thing divided by 5. That is the answer. Best part, mass is gone, even radius is gone. Only thing that remained when you solve this was that number 2 by 3, which will be different if it was a solid sphere, which will be different if it was a solid cylinder, because it will be half mr square. It will be different if it is a ring or a hollow cylinder. So the point is, this acceleration is always, independent of the mass and the radius. Independent of mass and even the radius, but only depends on the shape, not the size, what kind of geometry it is. Solid sphere, hollow sphere, that's it. So if you take a solid sphere of less mass, more radius, less radius, big mass, small mass, all those solid spheres will have same acceleration because mass and radius will never come into picture. It's a very interesting thing. Okay? Irrespective of the mass and radius, it will all have the same acceleration. Is that clear? Awesome, guys. Awesome. So there was a question maybe like this over here. Maybe you can solve it. A solid sphere and a hollow sphere of the same mass and same radius. Actually, mass and radius does not matter. So ignore whether the mass is same or not. Ignore because it is not dependent only. It is to be ignored because it is anyways not depend. It does not depend on the radius and the mass. Let the time taken be T1 and T2. Who will have more time or less time to reach the bottom? So let's do one thing, simple. If I take a solid sphere, the acceleration will be G sine theta by 1 plus, I will have 2 by 5 mr square by mr square. Solving this, mr square cancels, 1 plus 2 by 5 is 7 by 5. So 5 will go on the top, G sine theta whole thing divided by 7. That's for the first thing. If you talk about hollow sphere, we just did it. G sine theta 1 plus 2 by 3 m r square divided by mr square. Mr square cancels. 2 by 3 is there. So it will become 5 by 3. So 3 goes on the top. 3g sine theta whole thing divided by 5. Now tell me which of these accelerations is bigger or smaller. So for the solid sphere and hollow sphere, it's T1 and T2. So this is A2, let's say, and this is obviously A1. Who is more? G sine theta is the same, 5 by 7 versus 3 by 5, guys. Who do you think is more, 5 by 7 or 3 by 5? Quickly answer in the chat box. Quickly answer it in the chat box, guys. Yes. What do you think? Who is bigger? Who is bigger? Yeah. Answer the thing in the chat box. Yes. 1 or 2? 5 by 7 versus 3 by 5. 3 by 5, that number only, how much will it be? 0.8, no? 0.8, sorry, 0.6, my bad. 0.6, 0.6. 5 by 7, how much is 5 by 7? Approximately. Approximately, guys. Yes. 7 sevens are 49. So 0.7 approximately. So this is more than this. So more acceleration means it is faster. Faster. And this hollow sphere is basically slower. So whatever times they are taking, T1 and T2, if I compare them, fast means less time, slow means more time. So T2 will be more than T1. So hence option number 1 will be the correct answer, which is absolutely correct. T2 is more than T1. So this kind of questions can come in your JEE examination. Okay, based on this formula. I have kept a homework question for all of you to solve. It's based on equilibrium concept on ladder. I think you can easily solve it. Basically, there is a ladder and it is being supported by the shoulder of a person. Imagine this is our person. So draw the free body diagram, normal force, friction force, weight force, normal force and all of that. And the question is how much is the force given by the shoulder of the person? That's it. Or weight experienced by the shoulder of the person. That's it. So draw FBD, balance the torques, you will get the answer. Okay, solution is there on the next slide. I'm not showing it to you. And remember all the PDF, the smart notes, quizzes, tests of YouTube classes, even doubts you can ask for free using the Ved app, right? You can use it on Android or you can use it on the web browser. So make sure that you are just going down into the description box of whenever you are watching any video like this particular one. Where are we? Where are we? Yes, here. And you will see the link right over here. Ask with any doubts and it will open up. Just make sure you are signed in into Vedantu. That's all. Okay, free of cost. You can ask doubts of YouTube classes as well. Create your own questions and the notes also will be available. Okay, thank you so much. Have a great time. Take care. Hasta la vista. Bye bye.